Hello student, welcome to all in Sikander Physics classes. Now in this class we are going to discuss that's the important chapters, that is the gravitation. Yes, gravitation, you know what is the gravitation? Okay, one example I am going to give you. Whenever we toss anything into the space, what happens? You may have seen that the object are always comes towards the surface of Earth. Why it happens? Anything when you toss vertically upwards, it always comes towards the Earth's surface. It happens due to gravitational pull of the Earth. Means the planet or the Earth exerts a force on the object towards its surface, and that's why it happens when you leave, and it comes towards the Earth's surface. Means according to, we can say that the Newton's law of gravitation, Newton's gave the idea why it happens, why mostly the object comes towards the planets, towards the surface of the Earth. Okay, how many planets are there? You know that total 8 planets are there, and just in out of 8, one is the Earth is also. Okay, so today we'll discuss about the Earth, how it revolves around the Sun. You know that the Sun, if you will take, this is the, suppose that the Sun, okay, and Sun having, okay, the lights which spreads around, and you take, this is the elliptical path, okay, elliptical paths, not in the circles, just like, okay, just like what we can say, in the shape of the orange, in the shape of the egg, like that you can take. Okay, so you know that the when the ray of light will spreads like that, okay, suppose that, okay, here is one planet, it may be here, maybe all around, total 8 planets are there, and all planets, okay, revolve around the Sun. Okay, but you know that the planets when moves, some planets are close to the Sun, some are away from the Sun, but all having the same nature to revolve around the Sun in the elliptical forms. And what happens, and which are close to the Sun, they take less time intervals to complete one, okay, circle, or to complete this path. But those who are away from the Sun, they have to move the longer distance, so they takes more time. And you know that all the light spreads, so the planets which comes in front, the ray of light falls. So what happens, suppose that if we have any, suppose that you take the, I have one book, if one side the light will spreads, this will be the in front of the light, so definitely these positions will be the sharp and bright, which will appear nicely. But just opposite, it will be shadow, dark, and that will not appear. So what happens, whenever we see, okay, in front of the lights, it appears, and we say this is the day. Okay, so like that the sunlight appears, okay, on the planets, and that becomes the visibles, and just opposite of that it becomes the dark, we say this is the night, and this is the, okay, and all takes sometimes, all planets moves around this. So one scientist, that is name of the, okay, Kepler's law. Kepler gave the ideas that having the 3 laws, one is the law of orbit, law of area, and law of time periods. There are 3 laws. So all 3 laws I have explained here. First, the law of orbit means all the planets revolve around the Sun in elliptical path, Sun being at one of the 2 foci of the ellipse. Means all the 8 planets moves, and also moves on its, okay, axis and in the elliptical paths. And so this first laws represents the mostly all the planets moves in the circular forms or elliptical paths. Second, we have law of areas, the line joining the planets to the Sun sweeps equal areas in equal interval of time. Means when it moves like as a tops, So equal interval of time takes whatever it sweeps on that basis. Another law of time period, that is the square of the time periods of the planets around the sun is directly proportional to the cube of its basis. Means suppose that if there is the radius, r is the radius of any planets and t takes the time periods. Why? Because definitely whenever it will move in the elliptical paths, so according to these statements, the time periods will square and directly proportional to the cube of the radius. So suppose that if there is the t1 and t2 and t1 having the radius r1 and t2 having the radius r2. So according to this statement, how you will write here? You can write t1 by t2 proportional r1 cube by r2 cube. Can we write yes? And if you will remove this one, so here will be t1 by t2 equal to k r1 cube by r2 cube. Can we write yes? And you know that in SI unit k is equal to 1. Therefore t1 by t2 is equal to r1 cube by r2 cube. So this will be the comparison whenever you will take the two planets, okay, and which having time t1 and t2 and radius r1 and r2. So according to the Kepler's law of planetary motions, we can see that mostly all the planets revolves in the circular paths which having some time periods to complete, okay. Some takes 365 days, some takes less, some planet takes more, according to the distance close to the sun. Okay students, so next class we will discuss what is the gravitational pull, okay, centripetal force, centrifugal force, and first you will write this one, make a notes. This is very important chapters. Okay, thank you.